Here's an example of a level 2 problem. Ammonia is made through the reaction of hydrogen gas and nitrogen gases to create ammonia. If I have 5.50 grams of hydrogen, so that would be this, and it reacts with 5.50 grams of nitrogen, then how many grams of ammonia are we going to produce? And when we make this calculation, we'll be determining the theoretical yield of ammonia. Notice in the problem, they gave us that we produced 20.4 grams of ammonia. That is actually equal to the actual yield. So when I want to calculate a percent yield, I can use the actual and the theoretical. So what is the actual yield? It's the 20.4 grams of ammonia. Okay, what is the theoretical yield of the ammonia? And we're going to have to do a calculation. The first one would be from the nitrogen to the ammonia, and the second one would be from the hydrogen to the ammonia. Notice that both of my givens will be used to calculate my amount of ammonia. So I'm going to start with first the nitrogen. So I'm going to take 5.50 grams of nitrogen times, draw a line, bring down grams of nitrogen, and I'm going to go to a mole of nitrogen by going to the periodic table and adding up the mass of nitrogen, which is 14.007 times 2. That's going to get me 28.014 grams. Times, draw a line. Remember to bring down moles of nitrogen. And here I want to do my mole to mole ratio from moles of nitrogen to moles of ammonia. It's going to be 1 nitrogen to 2 ammonia. And then times, draw a line. I'm going to do one more step. Bring down moles of ammonia. 1 mole is equal to the grams from the periodic table. I'm going to go add up nitrogen plus hydrogen times 3, and that's going to give me 17.031 grams. Now I can calculate the answer that I get from this, and it equals 6.69 grams of ammonia produced. So that's my first potential theoretical yield, my first possibility, theoretical yield possibility number 1. Now I'm going to need to calculate the other possibility based on the hydrogen that I've been provided. And so now we will calculate for hydrogen. If I have 5.50 grams of hydrogen, bring down grams of hydrogen, and we're going to get the mass from the periodic table. That's going to equal 1 mole of hydrogen. The mass is 1.008 times 2, which is going to give me 2.016 times, draw a line. Now I can bring down moles of hydrogen, and here's my chance to do a mole to mole ratio from hydrogen to ammonia. So go from moles of hydrogen to moles of ammonia. It's going to be 3 moles of hydrogen to 2 moles of ammonia. Time, draw a line, and then bring down moles of ammonia. And just like before, 1 mole of ammonia is equal to 17.031 grams from the periodic table. Now we will calculate the answer we get for this, and we get 30.98 grams of ammonia. And that is going to be our second possible theoretical yield. So theoretical yield number 2. We compare the two theoretical yields, and the smaller one is going to be the real theoretical yield. The larger one is nothing. So our theoretical yield of ammonia is going to be 6.69. And what we used to get that theoretical yield is going to be our limiting reactant. That means that what we have is an excess of the hydrogen. In order to find the percent yield, remember percent yield is actual divided by theoretical times 100 equals a percent. So the actual yield was 20.4 divided by the theoretical yield was 6.69 times 100, and that will equal, it's going to equal a very large number, 305%. And that's because this number is far too large to be the actual yield, because theoretically we can only make a maximum of 6.69 grams. So this is a very unrealistic number, but that is the numbers that we had in this problem, so we will go with it.